This is Team 9's Project 3 presentation, Smart Streetlights, by Ashley, Angela, Kevin, and Shannon. The problem we decided to focus on was that by leaving street lamps on at night when there are no pedestrians or vehicles around for miles, a city will waste millions of taxpayer dollars on running these lights, as well as waste lots of electricity. After doing some research, we realized streetlights account from 25 to over 50% of a city's electric bill, and that the International Dark Sky Association estimates 30% or $3.3 billion of all outdoor lighting in the US alone is wasted each year. Here are a few roads one member of our team took that show empty roads at night with all the streetlights on. Since this is such a big problem, we decided to see what others have done in hopes of finding solutions that would be ideal to this issue. Most places, such as New York City, Phoenix, Arizona, and Seattle, stick with adopting the practice of switching to LED lights as it's the most common way to save electricity. A European company named Tivolight produces light sensors in hopes of saving the environment by promoting the use of sensors. Cities such as San Diego have implemented light sensor systems to save cost and energy. The reason we decided to tackle this issue was because all of us noticed when driving down highways and roads at night how much electricity is wasted when you're the only car for miles on end. This also focused on the issue of energy conservation, a major topic during this day and age, and we noticed that focusing on the electricity used by streetlights can help with energy conservation.
After researching several methods of detecting light levels, pedestrians, and vehicles, we decided on using the microbit's built-in light sensor to determine if it was nighttime, an ultrasonic ranger to detect a nearby pedestrian or large obstruction, and the microbit's built-in radio receiver to detect a radio transmission from vehicles. Note that this would require that vehicles have a radio transmitter installed. You might be asking, why are we using two sensors to differentiate between pedestrian and vehicular traffic? Let me explain.
If I'm a pedestrian, the only street light I need to be on is the street light that I'm under. Meanwhile, while you're driving, it'd be nice to have more than just one light on so you can see what the road ahead does.
By using radio receivers to detect vehicles and ultrasonic rangers to detect pedestrians, we can have a greater detection radius for vehicles than that of pedestrians. Because of this, we can allow vehicles to turn on multiple lights from a fair distance away, while pedestrians can only turn on a single light that is right next to them. Shown now is the functional block diagram. First, the street light will take in ambient light levels through the light sensor. If the sky outside is bright, the LED will be off, and the ranger and receiver will be inactive. However, if it is dark outside, the ultrasonic ranger and radio receiver will become powered. If an object is within the proximity of the ranger or the receiver receives a signal, the LED bulb will be turned on to full brightness. If neither is true, the LED bulb will only be at 20% brightness. Below is also a functional block diagram showing that the car will transmit the radio signal to the street light.
Okay, turn them off. Okay, turn them on.
Yes.
For project management, we wanted to make a sensor system that will cause a light to become brighter if the amount of movement reaches a certain threshold. Then, ensure the system does not get triggered unnecessarily. Thirdly, confirm that the implementation of our product will allow for cities to save money and produce less light pollution. And fourth, provide a sensor system that ensures the safety of the people in the areas where it is used. For engineering specifications, with the first being production cost, in US dollars, our minimum was $2,000. Our target that we're looking to get is $1,000, and with the max being $4,000, which is not ideal. For our second metric, we have functional performance in years. Our minimum is probably 5 years, which is more realistic. Then we have our 10 years, which is our goal before the system would be have any maintenance into it. And our max goal is working indefinitely, where the system works regardless of any outside functional problems. Thirdly, we have the energy efficiency, which is in kilowatt hours of each bulb. The minimum is around 20, but the more realistic target that we're going for is 100, with 250 watts as our max, as a standard street light wattage in kilowatt hours. For number 4, we have the water and environmental proof of the system. In that, with no units, in that the system can last up to 15 years. After 15 years of environmental hazards, we wanted to make it where it'll last up to 20 years without fail, and with our max goal being working indefinitely. But obviously, that's not realistic of a man-made system. So, if we look at the evolution of the design of the smart light system, it started out very simple with only one sensor and signal, and then we added not only the light sensor to detect whether it was daytime or nighttime, but also the ultrasonic sensor in regards to how close a person is to the light post. And the simple design was just that the car transmits the signal, the light receives it, the light will be lit during the duration the signal is transmitted by the car and received by the light, and when the signal can no longer be received, the light turns off.
During the course of creating our project, we did have to decide against some certain alternatives when deciding which components we were going to use. So, for example, we decided against using the passive infrared sensors simply due to the fact that they can detect changes in movement. So if somebody is sitting on a bench next to one of our lampposts, then it wouldn't necessarily detect this person, and the light might turn off, which would be a safety hazard. We also decided against using a network of lampposts. In this way, each lamppost could be an individual unit, and if one fails, the others are still working, and that doesn't cause a safety issue. The idea for the car radio transmitter was based on how pilots will use their radio transmitters to turn on the lights at an airport. We decided against using cameras or data collection systems due to the backlash faced in San Diego regarding an invasion of privacy. If this happened to become a standardized product, then we would want everybody to feel like their privacy is not being invaded, and we want to keep the safety of the people using the product at utmost importance. The great things about our solution is that we aren't keeping the lights on at full blast at all times during the night. We're keeping unnecessary lights dim, and by doing this, we reduce the amount of electricity used and in turn spend less on taxpayer money on these lights. We always keep the lights dim when it's dark, so it's safe for pedestrians at all time, as they can always see ahead of them. However, the brightness level does change with necessity, so the closer that the pedestrian gets to the lamppost, the brighter that the light will get. The last thing that's really great about the system is the system solves 3 different problems within one outdoor lighting system. So we're solving the issue of a light sensor that's turning off during the day and keeping on at night. We have a transmitter that's supposed to go in the car, and we also solve the lighting issues for pedestrians that need to see in the dark. There are some cons to our solution. For example, lighted streets are often linked with lower crime rates. So when trying to implement this cost-efficient lighting, there is potential for an increase in crime. For example, dimming the light to 20% when nobody is nearby might cause an increase in crime rate. Sensors could be set off by larger animals. In our first model, we did account for smaller animals such as squirrels or small dogs. However, we have to improve the model by accounting for larger animals that are passing by the sensor. The ultrasonic range could be upsetting pets that can hear higher sound frequencies, which could become a problem. And the requirement of a radio transmitter in cars could be difficult to implement at a large scale, as this could be considered an invasion of privacy and cause some backlash. In conclusion, we'd like to improve our project by perfecting the sensor's ability to detect traffic accurately. We've also considered the idea of sending signals to lights upcoming so they can turn on and the person or vehicle can see further ahead. We've also wanted to seek an alternative to ultrasonic ranging, which would allow the person's proximity to be detected without upsetting any pets or animals due to the high frequency sound waves. Using plates underneath the road to detect oncoming cars and pedestrians will also allow us to opt out of using sensors and transmitters in each car, which could prevent the backlash from that in our cons section. Thank you guys for listening to our presentation, and we hope you enjoyed learning about our smart streetlight.